So, welcome back. New week. Now, how many weeks till the end of the 9 weeks? 2. 2 weeks till spring break, and 2 weeks till the end of the 9 weeks. So that means you have, whatever your grade is, you got 2 weeks to get it right. So this week, here's the tutoring schedule this week. I'm still here every morning at 7-ish, and depending on the day, I know tomorrow, I'm here to the bell. Friday, I'm here to the bell. Wednesday and Thursday, you usually have meetings. This is Murrow. Do we have a meeting on Wednesday? You know which one? Or no? Taxi? Something else? Okay. So I should be here every morning except for Thursday at 8 o'clock. Okay? Is everyone with me? So you know you can come see me in the morning. And you know after school you can see Mrs. Marrero tomorrow and me on Wednesday. Okay? So I'm here. Those are 2 days you can get after school tutoring. Tuesday and Wednesday. Has everyone heard that? After school, Tuesday and Wednesday. Now, not today. Thursday is not preferred. But if you have an emergency, maybe. But Tuesday and Wednesday. Now, we need to talk about radicals. So, first things first, square root of 121. Now, you could type that in your calculator, but I hope you might know what times itself is 121. What do you think? 11. Okay? Now, if you didn't know that, it's okay, but I want you to know that. 121 is a square number, because 11 times 11 is 121. Now, on number 2, there's 2 parts to it. Does everyone see how number 2 is a little different? So first of all, what's the square root of 4? What times what is 4? 2 times 2 is 4. Okay? Now so we know what the square root of 4 is. It's 2. Now here's the question. What's the square root of x squared? When you square root something, you're dividing that power by 2. So 2 divided by 2, or they cancel out and they just give you x. Okay? So 2x is the square root of 4x squared. You know why? Because 2x times 2x is 4x squared. Boom. Now, over here, what's the square root of 16? 4. Now, there's a negative out front. So make sure you bring down the negative, and then the 4. Now, again, cut it in half. X to the 4th power squared, right? But x squared. Okay, record. Now, got some notes to do on reducing radicals. Now, if any of y'all are in my geometry class, or have taken my geometry class, it's going to look very, very familiar. It is what it is. Okay? So, this is stuff you learn in geometry, so technically all of y'all should know this perfectly. However, we're going to review this, because you got to know this factor tree stuff. Factor tree, reducing radicals. I'm going to make you like it because it's going to be fun. I'm about to tell you a fun story. It's birthday fun, right? Pass one back. Not yet. Working on it. Oh, all right, here we go. And we are here. Now, these first boxes are pretty easy because you're just telling me what squared is this number. So what squared is 4? 2 squared, right? Did you know that numbers can be square, not just shapes, right? All right, so check it out. Everyone's paying attention. We don't got headphones in our ears, right? Please. Now, 9 is also a square number. What squared is 9? Okay, so keep going all the way down. You get 4 squared, 5 squared, 6 squared. Now, these are easy to fill in, but here's the thing I want you to know. I want you to know these square numbers. I want you to just recognize 16 is a square number. 25 is a square number. 36 is a square number, right? The harder ones might be 7 and above. So 49 is a square number. 64 is a square number. Okay, 81 is a square number, 100 and 121 are all square numbers, right? By the way, now, what about backwards? Square root of 4 is? Okay, this is easy. Square root of 9, 3. You get the idea. Fill it out. So if you square root a square number, you get a whole number. But if you square root a non-square number, you don't get a whole number. Okay? Now, at the bottom is where we're doing the reducing radicals for today. You got to know how to do it. I'm going to teach you the way. And it's time for story time. Put it away. You definitely cannot do it on the calculator. That's why you've got to pay attention and understand this method. So everyone's going to be locked in, looking up here, right? All right, locked in. No, just locked in. All right, so at the bottom here. Now, I could read all this, but I'm not. I'm going to show you how it's done. So, first things first, we got to know what the word prime means. Y'all know what prime numbers are? What are prime numbers? Well, I want to know from y'all. Y'all know what prime numbers are? Any ideas? 7 is prime. Now, why is 7 prime? Okay, so the factors of 7 are only 7 and 1, right? It can't be broken down by another prime number. So what's an example of not a non-prime number? 3 is prime. What else? Okay, so 4 can be divided by 2. Yeah, see what I mean? Like, if it can be divided by some other number, besides 1 in itself, that's a prime, that is not prime. So 6 is not prime, 10 is not prime, okay? So here's the deal. What we're doing, so let's see if we know our prime numbers. What's the smallest prime number? 1. It actually is 2, okay? 1 is not considered prime, okay? So 2 is 3 prime? Yeah, 3 can't be broken down by anything. What about 4? 4 is not prime because it can be broken down by 2. What about 5? 5 is prime. Nothing breaks it down. 6? No. Okay, so there are a lot of odd numbers. Even numbers can be divided by 2, so you're right. Even besides 2 cannot be prime. Well, anyways, all that to say, the smallest prime number is 2. So what we're going to do, when we do a factor tree, it looks like this. So you got your square root of 50. We're not typing it in the calculator, right? We're not getting decimal. We're going to break it down with a factor tree. Now, I find that name ironic because it's not really a tree because it's growing downwards. It's more like roots, but whatever, okay? Okay. Let's try the smallest, hold on, let's try the smallest prime number, which is 2. Does 2 go into 50? It's even, so yeah, 2 times what is 50? 25. So write the smallest prime on the left, and then the other factor pair on the right. So 50 is 2 times 25. Now, here's what I'm going to give you suggestions to help you not get confused. When you break down a number, cross it out. That way you don't think 50 is still there. 50 gone, okay? Now it's 2 and 25. Since 2 is prime, forget it. Go to 25. We're going to break that. Hold on. Always start with the smallest. Does 2 go into 25? Now here's how you can tell. You type in 25 divided by 2. If it doesn't give you a whole number, then it doesn't work. 25 does not divide by 2. What about 3? Does 3 go into 25? You don't know, so let's try it out. 25 divided by 3, not a whole number. So no, 3 does not go into 25. Now 4 is not prime, so forget 4. 5, hey, it is 5. So 5 times what? 5, okay? Cross out the 25. And since 5 is prime, that's it. Now, that's the first step. Make your tree, okay? Now, here's where it's going to be story time. Mr. G, y'all listening? Okay? Now, spring break's coming up, and Mardi Gras, blah, 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 and whatever. So, let's talk about, hold on. I want you to listen and not talk. So, everybody listen. This is a story about a party, okay? And it was such a cool party. What's another word for cool? Radical. There was a radical party, all right? So, there was this radical house party, and guess who came? Hold on. So, 5, 5, and 2. These 3 prime people came to the radical house party, and just like any teen drama, okay, there were 2 numbers. They saw each other across the room. They realized they're so similar. They wanted to become a pair, a couple. So, Which two of these are the exact same number? Circle the pair. It's so cute. What a cute couple. So cute. Now, let me tell you, this is a really sad story though, just like any teen drama. Now, now check it out. Whenever they become a, whenever they become a couple, okay, please, okay, when they become a couple, listen. So, couples like to go out on dates, right? So when you think of the circled stuff, you're gonna think going out to the left. So they're gonna go out here. Now here's the tragedy, right? For some reason, there was landmines in the front yard. I can't tell you why, okay? But one of them is gone. It's so sad. Tragedy. I can't. It's sad. It's just sad. Okay. Now here's the deal. The 1-5 from the couple. We said couples go out. So over here I'm going to put 5. That 1-5 represents the couple. So sad. 1-5. Now, no. Now on the inside, guess who's left over? The loners. We have a loner 2 that's still going to be hanging out in the house. Okay. All right. So I'm the storyteller. So here's the deal. Couples go out. Loners stay in. That's the reduced radical form. Okay. That's all you got to do. So that's it. For this one, that's the easiest type of one where there's one pair, one loner. That's it. How is it a bit? It was there to begin with. Not a baby. No, wrong. Now, okay, example 2. Here we go. Let's do the factor tree. We always start with what number? Sorry. What's the smallest prime? 2. So let's break it down. Does 2 go into 24? 2 times what? Okay. And then cross out 24. Goodbye. 12. Now 12 is even. Anytime you have an even, that means 2 goes into it. 2 times what? 2 times 6. 12 is gone. Okay, now 6 is even. Does 2? Okay, 2 times 3. And does 3 break down? Because it's, what's that P word? Prime. Okay, now, do I have any pairs? Pairs. Pair of 2 and so sad. Now, this time there's 2 loners. Okay? They're incompatible. They cannot become a couple. Now here's the deal. Draw your radical house party, radical sign. Now, what goes out? Stop. Just stop. So, the 2 goes out. The circled pair 2 goes out to the left. Now here's the deal. What happens when I have more than one loner? The answer to every time I ask you a question, what do I do if there's more than one, is going to be what? Multiply. So the 2 and the 3 on the inside, multiply to make 6. Don't put 5. That would be the thing people do that's wrong. Now, pairs go out, loners stay in. If you have more than one, you got to multiply. That's the rule. Okay? Let's try example 3. 180. It's even, so 2 times what? 90. 90 isn't a 0. That's even. 2 times what? 45. Now, let me guess. You're going to want to do 5 times 9. No. I want you to use the smallest prime number. Does 2 go into 45? No. So the next one you want to try is 3. Does 3 go into 45? It does. Okay? Now, let me tell you why I'm being that way. If you always use the smallest number, your pairs will be next to each other. But if you skip around, your pairs could be all far away, and then you'll mess it up. Okay? So 3 times 15. 15 is 3 times 5. Now, do I have any pairs? Pair of 2, pair of 3, and guess what? And double destruction. Now, we have a loner of 5, right? No, that's not how it works. But we have the radical house party, the 2 and the 3 multiply on the outside, remember, because that's what I'm going to ask you. What do? Multiply. 2 and 3 gives us 6. The loner on the inside is 5. Okay? So again, following along. Pairs go to the left. Loners stay inside on the right. If there's more than one, they multiply. Okay? All right. Now it gets a little more complicated. Hey? What? So each of these are going to get more complicated. It's okay, I'm hanging with you. So 1,260. It ends in a 0. It's even, so 2 goes into it. 2 times what? 630. Okay, that's ends in a 0, so it's even. 2 times 315. Now, does 2 go into 315? No, because it's odd. Does 3 go into 315? It does, right? So 3 times 105. That, if you didn't know that, you could divide it, right? You could do 315 divided by 3 and get 105. Okay, now 105. Some of y'all want to jump to 5, but before you try 3, does 3 go into 105? What do you think? What do you think? What do you think? Okay, 3 times 35. Thanks, Dave. Yep. All right, 5 and 7 multiply to make 35, right? Now, what pairs do I have? Pair 02, pair 03, loner 5, loner 7. Now, if I have more than one pair and more than one loner, again, multiply, right? So on the outside, it's going to be what? 2 times 3 gives me 6, right? And on the inside, 5 times 7? 35, right? 5 times 7. Now, let's make it hard. It's already on there, so I'm not making it hard. It's already there. So, okay, is everyone with me? Look. On number, example 5. No, so check it out. What's different about 5? Not a what? There's a coefficient. So, what if there's already a number outside? Okay, so think of that number already outside as a pair that's already out. So what do we do with pairs? We usually circle them, right? So here's my suggestion. Is everyone listening? Look. So if you have a coefficient already, okay, I want you to circle it. So think of it as a pair that's already outside, okay? That way when you get other pairs, you'll multiply them together, okay? So here's what I mean. Let's break down 76 2 times 2 times what? 38. Okay? And then 38 is 2 times. Now does 19 break down? Try 2, don't work. Try 3, don't work. Try 5, try 7. Okay. So 19 is a what number? Prime number. Now, so do I have a pair here? Pair of 2. Boom. Gone. Now, the pair of 2 and the loner 19. Now here's what most people were going to write. 2 squared to 19, and that's wrong. Because there's a 5 out here, right? Well, the 5 and the 2. Perfect, okay? 10, hey! Yeah! 10 squared to 19. Woo! So it's not, you just have to right. You just have to not forget the 5, okay? Please don't. So how do you remember? If you circle it, you might think, okay, 2 circles. Then you forget. So don't forget. Don't. No. All right, everyone with me. So 2 more for the notes. You know me? Now, example 6. Now this one looks maybe more intimidating because of the x, but I'm going to show you. It's not that bad. 48. First of all, do the number. 2 times what? 2 times what? 2 times what? 2 times 24. I'm going to only cross out the 48 part, and then 2 times 12, and then 2 times 6, and then 2 times, and then I'm your teacher, right? So go with that one. Now, you break it down by 2's, and then the last one is a 3. 3 is prime. Okay. Pair of 2. Pair of 2. Loner 3. Now here's the deal. Before we keep going, how many x's are represented here? 5x. Y'all know x to the 5th power means x times x times x times x times x. Check it out. This means, go ahead and write 5 x's here. Now, if I have the square root of x to the 5th, they're asking you how many pairs of x. So you can circle your pairs just like with the numbers. So I have a pair of x, and I have another pair of x, and then I have one loner x. 5th wheel, yeah. So now, what's going to go outside is my circled stuff. So I got a 2 times a 2, which is, leave space here, 4, and then I have an x times an x, which is 4x squared. When you're multiplying the x times x, it's x squared. Okay? Wait. So what's left over on the inside? What is this? 3, and what's the left over here? X, right? So right here, 3x. Okay. You're going to see them, so I want you to get used to them. Now, one more, and then you can ask me interesting questions. Okay? Now, so let's try. You can do it. Now, this one's probably the craziest one so far, but start on the inside. 105. How do you get this x squared? Okay, backing up to number 6. So you see out an x and an x. Two x pairs makes x squared. Okay. Now, example 7. Let's break it down. 2 does not go into 105 because it's odd. What about 3? 3 times what? 35. 35 is going to be 5 times 7. What do you notice about those prime factors? Hey, wake up. Are there any pairs? If there are no pairs, the number is not going to actually, nothing's going out. No, like there's nothing to change about. So here's the deal. 105 is going to stay here. Okay. Now, x to the 9. So you can write out all those x's if you want. 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, again, I'm showing you the long way to do this, but this is the way most people see it visually. How many pairs of x's are there out of 9x? So 1, 2, 3, 4. 4x. X times x times x times x is x to the what power? 4 power. Now, here's where it gets tricky. Don't get tricked. Isn't there an x already outside? So I have the 1x outside, and I'm bringing 4x to the outside with it. That's going to make a total of x to the 5th. The 2 is still out front, so this stuff came down, and these 4x's came down too. Okay? I know that's tricky, but you started with an x, you got 4 pairs of x, that makes 5 total x, 5th power. What's my loner here? A 1x stays inside. It is weird, it's kind of tricky. Is there a better master teacher way to do this? I don't know. Miss Murrow doesn't say there is, and that's it. That's the best. Okay. So I'm going to pass out the assignment.